Alright, I got the crank all cleaned up. It definitely needed clean. It was filthy. It looked like it was clean, but it wasn't. Not even close. So the biggest problem with these cranks is the crap that collects up under here. When the motor's rotating, it's like a centrifuge. All the crap goes to the outside. And these big fat wheels, it collects all the piston residue up under here. So it's got this gray junk on there. So you still get stuff even coming off now, even though it's been cleaned several times. The only way to get this stuff really off is to blast the damn stuff off. But anyway, it's a lot of it up in there. So anyway, it had chunks and chunks of it hitting me in the face when I was blowing on it. So I got most all of it off. So it was on both sides. Plus these holes are all full of crap. They were blowing all over me. This side here is not as bad because it's not as thick, but it still had junk up on there, collected up under these edges. So make sure you clean all these areas up. So even though it doesn't look like it's very dirty, it was very, very dirty. You got a fresh motor going together and you have all that crap come out. Not nice. Okay, so now this is done. I'll go ahead and put the, we'll go ahead and install our new bearings on here in a minute. So let's get that hammered. So first thing I'm going to do is get the tool we're going to need to hold the flywheel. So it's one of the two tools. You got the S&S bolt pattern here, or dowel pattern, you got the Harley dowel pattern. We're working on a Harley, so we're going to use the Harley pattern. That would be the pattern that was in these two holes right here on the side of the wheel. So we just hold this in the vise, and we can hold the flywheel. Okay, now we just put our flywheel in a hole over there. That just means you just pick it up like that. Nothing to it. Now those rods are dry in that motor now, so you have to make sure it gets pre-lubed when you assemble it. So when you have to bolt the case together, you put a bunch of oil on top of the rods there and working on the end, spinning around, put more oil in there and spinning around. That way you get oil worked into the bearings, because they're dry right now after all that cleaning. Okay, so now we're going to work on our tension bearing here. So we need our tool for putting it in, which is over here. Now, Timken bearings have to be pulled on or pressed on, not pushed on. Those are two totally different things. So right now, if you take this bearing, we take it over here, we stick it on here, and we beat it on with a hammer, or we put it over there in a hydraulic press and push it down. What's going to happen is you're going to take this flywheel, it's already trued, and it's going to go like that, and it'll be way out of true. Because when you're pushing on this, you're pushing on that crank pin, because that's what's holding that flywheel to this flywheel. So what you actually do is you press it on by pushing the bearing here by pulling on this shaft. So you're actually doing a reverse action what you think you're doing. That's what this tool here does. Bolts on the end of the crank right here, and then you got your sleeve that goes over the crank, which pushes on the bearing race right here. So you're actually pushing the bearing down and not pressing it down. Even though you actually are pressing on it, but it's a difference. It's not an external press, it's an internal press because you're holding the shaft. You're just pushing the bearing. If you put in a hydraulic press, you're pushing the whole thing down. So anyway, totally different thing. And if you beat on it with a hammer, it's the same thing. You knock the flywheel out. Now this I made an extension piece here to work with the later motors, and I also added a Torrance and thrust bearing in here, so you got a lot more pulling power for the same amount of torque. Or pushing power, I should say, not pulling. It's kind of how you want to determine which way you're going. One way you're pulling, one way you're pushing. See, we're actually pulling on the shaft here by pushing this one down. So you can call it whichever way you want. Just don't mix them up. They are different. Okay. So take some oil. That'll be our famous assembly lube. I just put on top of the bearings right here is what I do. Just like that. Put a layer on the inside, see? You just hold the center and rotate the outside, and go ahead, it'll lubricate down in there. You see how the grease is working its way in, or the oil. It's thick like grease right now because it's cold, but it's oil. Okay, after you get that worked in, you go ahead and put it on the crank. I'm not using that one now. Okay, so we're over there on the crank now. Usually what I do is I take the spacing shim wash and I put it in right now too, just to push. Now this will push right on the end of this, see, like that. Okay, so I'm going to do this. First it tightens down on the crank, and then you spin this down to tighten the bearing. Push it down. After you get it going, you recenter it. Do it again like that a couple times, and it goes down easier. You hit a high spot there, so I stop, recenter, hit it again. I go down about 2 inches down, so it takes a little bit. Warms you up. Good upper body exercise. Actually works the whole body because I'm pivoting off my feet. Okay, tighten it down and unscrew it. All right. Whew, that's a good workout. Taking my sweater off to keep all this work out. Okay, so the bearing is now pushed all the way down against the shoulder of the crank there. Make sure you do not forget to put your shim washer in there. Very important that you do not forget to put that in there. I did not measure yet. I'm just going to put it together and see what happens here. We're going to go for it. For better or worse. Okay, we're going to take our nice clean case over here. It's all nice and clean now. We're going to go ahead and put some fresh oil on this for lubricant. Because everything is correct, we're not going back in here again. Chance of that being all correct is not even 50%. If I was smart, I'd add a thou to the washer right now, but I always like to check them to make sure. Okay, so that's pre-lubed. So I'm going to put that up onto the case over there. Box out of the way. Okay, I'm going to lube up this bearing now. So we do the same trick. So once again it's in there. Move it on down a little bit. And then we tighten this one up. Make sure your spacer's in the hole down there. So no matter what you do, you always check to make sure that that spacing washer is in the middle. tear up your crank real quick, the whole motor if it isn't. Rust brake. And I get a closer view so you can see what's going on down here. Okay, I can see a little better. Make sure the rods are over here where they belong. Not 2 in 1 and not under the case lip. That's kind of important. Okay, now what you do is you put torque on it. So it's like having it bolted together now. Unlike the S&S tool, which just shoves it straight down, it does not hold the torque on it like this. So this is a lot slower, but it's better because you can check stuff. Now see how that case is actually going down like that by itself? That means it's not too tight, most likely. It is actually loose. Hear it? Now Timken rollers will, they're at an angle so the gravity tightens them up because it's a wedge, cone, whatever. They go down and lock up. So to unfree them, you have to spin them down once or twice. Then you come back and check them again. So when you first hit it, it'll be more. And then see how it slowly tightens up. Now you have almost no clearance, see? Because now the rollers have wedged in. So to unfree it, you rotate around once or so. And your clearance comes back, see? If you give it a couple of laps, try not to bang the rods too much. See how loose it got? Because the rollers go back up. See, I'm actually lifting the whole case straight up right now. So, this bearing, which is pre-fitted, is fitted loose. Usually they're fitted pretty damn tight. This one's pretty loose because it's got a lot of free play. You're supposed to have 1 to 3, and we have that. Okay, so I'm going to take this back apart and take out a thou out of that washer and try it again. You know, this here goes on up top, and you put the pin in here to take out the shaft. And there's no way of duplicating what the real world numbers are, so any tool they say for checking in play, worthless. Does not work. Because every shaft has a different amount of press fit for the bearing. If the bearing's pressed real tight, it expands. If it goes on real easy, it doesn't expand. How do you duplicate that? There's no way of duplicating it. The same on the cones. When you press the cones in the case, they shrink. Well, that makes them tighter. Can't duplicate that. So those fancy tools don't really duplicate. You can give you kind of a rough starting point, but the real world is you got to put together and check it. Okay, so now this thing has to be pressed back apart. Now pressing on the crank's not going to hurt it because you're pressing the bearing off the shaft. You're only putting the pressures all on the shaft. There's nothing on the flywheel below it. As long as you don't drop it on the table when it comes out the other end, which has been known to happen. But I try to avoid that. So I'm going to go right to that press right there and use it again. So put it wide enough to get the crank in here. High enough to get it to slide in. And of course we gotta not hurt my back. Good luck on that. It's a good thing my back likes to hurt a lot. That's the way you do it with one hand. Alright. Now I can press it straight down. Oh, that's got torque on it. Now I take my rag, I push against the end of the crank, and I hold it up while I come down so I don't drop it. Like that. Okay, so let me put all these parts back over here. Whew. Time to strip down. I'm getting hot. There we go. I'm naked almost now, see? Down to my Tatro shirt. Okay, good deal. Yeah, I'm working too hard. Okay, this goes back in the stand over here. Take our washer off so we can measure the washer. Okay, that washer is too thick. So we have more to choose from. We have the one here that was the original one. And then we got a whole big bag full of them. All different sizes. And all marked so I know which ones are which. Okay, so now we get to pick out the one we actually need. First we need to grab a handful of these and pull them out. So these are the numbers on the mic, not the size. 4 means it's 4 on the mic, 5 means it's 5. The mic's better than caliper because they're all different. So you roll it on your arm, you get a quicker drop off. Okay, so this one here is a big one. So this is see, it's about 6.5 on the mic. So that would be called a 6. Okay, here's the one that came out of the bike originally. It's 5.5. It looks like what we need right there. See, that one is, oh, this one's 7.5. That's a pretty good, that's a big jump up. This is 7.5, not 6.5. See the mic. Now that had noticeable end play. The problem is this takes up more gap than 2 thou. Because you're working on an angle, so you tighten them up this way. You're pulling from both sides basically, but the angle is not 1-to-1 ratio. So now if I go to it, if I go to this one, it might get too tight. Now this bike is not really going to be driven real hard, but a little bit hard. So I'm thinking I want something a little bit thicker than the 5 to 5.5, because this varies a little bit. So we want a 5 bag. We're going to look something for 5.5 to 6 on the size. Yeah, probably closer to 6 than the 5.5 part. Okay, these appear to be all 5s. Even though, yep, we're in a 5 bag, that's probably why. Okay. 6 bag. Now for some reason, Timken has, they change it half the numbers when they go up. So they change it 5.5, 6.5, 7.5. That's how they do their numbers. So that's why it varies a lot. Okay, this one is 6 right on the money. Okay, I'm liking this one. It's 6 right on the money. So that takes 1.5 thou out, which will take out probably at least 2 thou for end play, which we had quite a bit because I could feel it. So that's a good starting point. It might be too thin, but we'll find out. That's what I want to do with this. Just put it together and figure it out. good for my back, actually, working this out like this. It beats going to a gym. Good upper body look out, but like I said, it is a whole body. Okay, that's tight. Case is moving on its own. That's a good sign. Got a little clearance in it. It's a nice high performance fit. Here's the clearance. Up and down, you barely get any. I like it. I'm going to zoom in there real close and see if you can see the jiggle in it, but I don't know if you can tell. You don't even really tell. But anyway, it's got it has some clearance. You can actually hear it, so I like it. I don't like them when they're really tight. You know, Harley likes them where they got like basically a press preload on them. I don't like that. That'd be 0 fit. They say 1 to 3. Yeah, they like them pretty damn tight. But I don't like it. These cranks are going to flex. You want to have room for movement. You know, got to have some breathing room in these things. If you don't have that breathing room in there, you're going to have problems. So I like a little bit of room in there. Like this is going to be kind of a semi-hot rod motor, not a race motor. He ain't going to run the piss out of it too hard on the street, but he's going to drive it, you know, have some fun with it. So it's better to be a little bit loose than tight. If it's going to be just a dresser bike, cruiser bike only, you can put this thing in with basically 0 clearance. You can barely even feel anything. After you assemble it, it'll center everything up. You actually get a couple thou of in play when you do it, when you check it. But it'll feel tight right now. So this one I can feel just a little bit. There's probably only about a thou and a half clearance in this right now. It's pretty tight. So I think this is ideal for this application. But we took out 1.5 thou on the shim, which is a lot. Okay, so I think we're good with this one. We can live with it. And once again, a pre-fitted part is not fitted worth a crap. But it ain't too far off. It was only 1.5 thou off, and it was on the loose part, which is pretty good. Usually it's about 3 or 4 thou on the tight side, which is bad. You gotta burn up a motor. This would not burn up a motor, just make a little noise. Probably you wouldn't even hear it. It would run good though. My race bikes are running 3 times that clearance. But I also run double the RPM too, all the time. So, all right, now this is where you hurt your back by lifting. So use your arm strength. See, now your back. That's why picking motors up doesn't hurt my back too much. Now bending over and pulling parts box off the shelf, that's what hurts my back. That's what did it last time. Picking up motors into it. It never does. Picking up backs of bikes do though, because you're bent over. It's that bending over part's what does it. Doesn't take much either, a few degrees. All it takes. Okay, so this is all done right now on this part. Now I need to work on the main bearing and set up the pinion bearing over here. So let me get all set up for that. I'll be back.